Right, so we are going to start with another Midland 77104 from our Mr benefactor Alan. Another Midland to go with his others. Sorted the power lead. He does have a background in computer repairs to component level. He sorted the power lead, cleaned the board, but totally dead. Well, before we connect it to that, we will connect it to the power supply. Now, I've already spent 90 minutes on his CTE preamp, and when I look at I did research where he bought it from on eBay, and I looked very carefully at the pictures, and it was already blown up when he bought it. He supplied transistors for that, but we're not actually getting anywhere. But I have ordered some other parts. And these days I'm having to order parts from eBay because things like BF244 transistors aren't available for my wholesalers anymore. So I feel like, although I'm trade, I'm having to buy retail. Kind of embarrassing. Right, well, it's dead, he says so. So chances are we need to take all the screws out. I'd like to drop these back to his intermediary on Friday. It's currently Wednesday. There is no chance of the preamp in that time scale, but there's every chance that we've got this. And then there would be 3 to return. Now let's pop the speaker off. And see if there's something really silly going on here. The actual screen's missing on this one. So the power switch goes down to there. Let's get a meter on the job. I would think these are going to be negative earth because they're too compact to be a floating chassis, I would have thought. So we'll just connect like that to our negative and just make sure that we've actually got. It's going to go to that choke. Except our negatives come off already. So as we can see, we've got 13.8 volts to the choke. Make sure picture in picture's off. So that's going to be one side of the choke. That's going to, I expect it to be the other side of the choke. It's going to find its way down to an on and off switch down here. I would have expected it's the back set of contacts. So it's not making its way down to the on and off switch. I'll be having to look at the circuit diagram yet. So what colour wire do I think comes out of that choke? The orange wire part of it. Nope. It doesn't look like the printed circuit does much apart from mount the choke. The output must go to wires. So back to our on and off switch. Connection there. And one there. When we switch the set on, we've got 13.8 volts. So it's not the on and off switch. So we do have an 8-volt voltage regulator, which is here. So we've got 13.8 volts going in. We've only got 0.8 coming out. 13.8 going in. 0.8 coming out. Just check the PA is getting power to it. So there's our output transistor. That's getting power. So our fault is, unless there's a massive short circuit and that's shutting down, but there's no heat there, the fault is that 3-legged regulator chip. So I think it's usually 7808. So we'll get that unsmoldered. So I may only have 9 minutes, but that was some fruitful fault finding. So it's a Samsung one. It's a 78M08. Just looking for you've got a scrap chassis lurking. Well, there's 77099 here. You can see all the tracks being ripped off by silliness, but it's already had the output transistor nicked, and I can't see that it's got one of these in the first place, so that's a non-starter. Going to have to get a new part. Right, so armed with a new one. This is a what? L7808. It's supposed to be an ST, but it looked a bit made in China. So it's a 7808CV. Now, if I remember rightly, the M version is 500 milliamps, so this is a more powerful version. Now, it doesn't need an insulation kit because the centre pin is ground, so we just need to put some heatsink compound on that. So the fact this is a more powerful in current version should be good, but why has it failed in the first place? there is the question for today. Heatsink compound RS 503857, made in the UK. So I'm going to take that break as soon as I've put this in. I'm not sure they've even put heatsink compound on the original. So that might be me doing a bit of an overkill. Or that might be why it's failed. Always mount these and tighten them up before soldering them, otherwise you're going to end up with putting strain on the solder joints. I could go to Mr Chippie's and get some spanners out, but I'm not. So we need to chop these a bit shorter. The 7808 isn't as easy to come by as, for example, a 7805, which of course is a 5-volt regulator, or a 7812, or even a 7824. It's one of the more unusual ones. I seem to recall we tend to import these. In other words, I don't think they just come out of RS's catalogue. I've still got 4 in stock, and seeing as I've only used 4 in 40 years, these aren't new old stock. These were bought less than 5 years ago. Some Wally has turned the soldering iron off, and there's only me sat here. I think the 90p these are not scary. Good. Right, we'll power it back up again. We are now lit, but with intermittent display. I just need to check the voltage. And there we are, 8 volts. Fantastic. We'll put that away. Oh, there's quite a few bars out on this, aren't there? Let's guess the channel. 3, 4, 5, 6, 7, 8, 9, 10, 11. Bit came back there. 13, 14, 15, 16, 17, 18, 19, 20. I hope it's not a deaf display. Right, quick check to see if we're getting anywhere at all with it. It's come with the factory original mic. Switch picture in picture on, and are we on the main meter? We are going to transmit, and we've got absolutely nothing. And go to the door and call it a day for this morning's session. Okay, so a couple of hours later I'm back. I've had an idea. And there's a possibility, of course, that the microphone supplied with the radio is faulty. So here is a microphone borrowed from one of our test sets. And we've also got no transmit. But there is a clue. The ammeter is changing. I'll tell you what, we'll carry on with this mic and put the customer's one to one side. So there's a clue on the power supply because it's giving us a different ammeter reading when I go into transmit. So at the moment it's drawing 115 milliamps. When I go into transmit, it's drawing 135 milliamps. So there's a possibility it is transmitting, but not actually all the way through the transmitter. And there's also a possibility it isn't transmitting at all. So I'm going to look at this printed circuit around this area for problems. Okay, so I've had a look for dry joints, and I've done a few, and we now got transmit. And we've got picture in picture on, yes, and tapping. Right, I'll get Mr Chippie to look at that though later. Not as I know what we're going to do with the display. So, dead set 7808 replaced. No TX RX, dry joints in VCO. So now we've got transmit, let's see what it's doing. It's doing more than 3 watts, that's good news. It's doing 3.2 watts. Let's change channels. Low power. is 1 to 310 milliwatts, and power consumption 979 milliamps. Deviation on this meter, wallow. One to wallow is non-existent. 1 2 1 2. Testing 1 2, testing 1 2. 1 2 1 2 1 2 1 2. Yeah, right. Well, something amiss there, isn't there? That's when you wish you got PA. We won't be doing that. Frequency. Everything's been on several hours. $27,791.03. So we should be able to bring that up okay. Or not. Yep. And receive. Let's get plugged in. Still got this attenuated thing on here. Let's see, let's look for the SINAD meter, and that's there. It's very good. 12 dB is 1.45. How can that be the same? Oh, it's 0.43. And 21. Squelch. Full squelch. Three millivolts, it's far too high. And threshold 0.9. S meter 100 microvolts. And we're getting S5, so it's 100, at the moment it's 265 microvolts. Wrong one. And on transmit it's 3 and it should be 4. Good. So at least it would be usable if it transmitted audio. I'll just check that's not our mic, this stuff. Go back to the customer's mic. Wallow. No. Testing 1 2, testing 1 2 1 2 1 2. that can be another dry joint in the VCO. Right, well, we'll go through transmit. So we're not touching the VCO coil because we've already ascertained it's transmitting and receiving on channel 1 and 40. It's never been messed with, that's fine. I'm going to print off a quick tune-up chart which I had prepared on a previous job. Right, here we go. How come this one isn't the labelled one? Where's that gone? You couldn't make it up, could you? It's just a photo. Okay. So, transmit we're in. Go out of the... put the right camera on. Going to the 4 watt scale. Is this the one that has I think this is the one with low power. Just flick it to low power. Yeah, that's low power on this set. That's peaked. We've had 4 boxes delivered of donations. So thank you, Mike. That's 3.6. And there's 4. So let's just see how balanced that is. 3.95 on channel 40, 4.05 on channel 1. Good. Tidy those up. I'll just get the low power to 400 milliwatts, especially when I actually switch it to low power. Bang on, 400 milliwatts. And let's see what current it draws now on full power. 1.02 amps. So for another, what, 80 milliamps, we've got another what? Good. It wasn't on channel 1, was it? Sorry, it wasn't on channel 20. Just do that again. 1.01. Right. We want all 4 bars to light. And all 4 bars do light now. Without adjusting. We should have 1 bar on low power and 4 bars on high power. I just remind myself which is the correct preset. And it's that one. Check we're still there. We are. So that's TX. That's low power. That one's receive meter. And the set's already receiving nicely. Thank you very much. Right, we'll do the receiver tune up, and we'll start with the oscilloscope. And do the detector, which is hiding. It's there. Yep, that needed a fraction of a touch. See, I could see it on the photograph. It might not be coloured in photo, but at least it showed me the hiding part. So remember the UK version, this is the better version than the UK. So we'll go over to the SINAD meter now and see whether we can improve on an already good receive. So you can see we're about 4 dB. So go through the front end. Well, that's made an improvement. Drop the attenuator. No, that's no change there. No change there. And a bit of an alteration there. So let's see what we've now got on the SINAD meter. I'll tell you what, it's red hot, this. Well, not physically. It's 0.36. So that's better than usual. 10 dB 0.31 and 20 dB 0.85. So we're going to put 100 microvolts on the signal generator to see what we're getting there, and we should get S9, so we'll adjust that for S9. And having done that, let's see if we can bring it up to plus 30 with the signal generator. We're on 100 microvolts, and with 300 microvolts, yes, we get the plus 30. So that looks as it should. And that brings us to squelch. So we'll go over to the extension speaker on the wall so that you can actually hear it. Not sure why the bash is backed in, the back is bashed in. So squelch to full. I'll just put this camera over to, I'll put the inset pitch over to the camera which is on the attenuator. So I want it to come in at 100 microvolts. We're at 1, 3, 10, 30, 100, nothing. 300, still nothing. So I'm now going to adjust the squelch preset, and one of these is squelch and the other one is deviation. So that's definitely squelch. So that's definitely deviation. So that one is TX, that one is RX, that is low power. So it would transmit was up there and across to those two, receive was those, and the detector was there. So it still needs a little bit more. No, that's minimum. So the best we can get with the squelch on maximum is 260 microvolts. Now there's no hard and fast rule on this. It's me who comes up with this 100 microvolts. So it's 260 microvolts, that's fine, as long as it performs right at the other end. So switch the signal generator to standby, turn the squelch down on the radio, set to threshold, signal generator back on, straight in at 0.3, and it is 0.3 that it's coming in at. So that's a bit better than 0.9 as it was before, though that would have been alright around scratchy corner. So that now leaves us with the deviation, and just in case it is the preset, we'll have a quick fiddle. 1 2 1 2 1. I'll put that walkie-talkie on, and we can actually hear it. Testing 1 2, testing 1 2, testing 1 2 1 2 1 2. You can hear the background noise coming up, so the deviation is doing what it should do. So there's going to be a dry joint. It's not. I'm sure it's not going to be a malfunction. Testing 1 2, testing 1 2 1 2. Microphonic as anything. So I'll get Mr Chippie to look at that, and we'll finish the video off shortly. Right, so the next day, it's Thursday, and I'd really like to get this back to him tomorrow, to his intermediary. This has been to Mr Chippie's department. He's sorted out the dry joints, he's sorted out display. The subboard on the front was coming away from the front, and tracks and all, you know, the kind of rigmarole. So it's now showing a sensible number. I've just done the deviation check with the test set behind me, just in case the Marconi's playing up, but it's not playing up. So there's picture in picture, and voila, we've got the 2.5 peak deviation there. Now I've fiddled with that, so I'm going to put not applicable. I mean, there was no deviation anyway. And of course I fiddled with it as part of the fault finding. So it's now 2.2 to 2.5 kilohertz as it should be. So it's dead set, 7808 replaced, no TX or RX, dry joints, yes, and then no TX audio, dry joints, display segments out, dry joints. So a lot wrong with this. Actually takes it to a service level 3. You wouldn't think it, would you? It's got all these dry joints, and why is the 7808 failed? You know, I've just got no logic for that. Yet the set, or has it just been put on one side for 30 years and it's developed the dry joints with age, which of course is going to happen. What happens at the factory is the component leads aren't cleaned properly, and that's why the dry joints wasn't that it wasn't soldered properly. It was soldered properly. It's that the component leads were dirty, and so these dry joints develop because of that. So we'll just finish it off. Front's not on properly, so we'll just tread. We did that. We've done everything, haven't we? Just a deviation, so we're done. We are actually done. So it just needs putting back together. I just hadn't filled in the form fully. So that was 100 microvolts. We'll test his mic in a bit at the end of the video. I'm just going to test it. I'll just test it now. I've no reason to believe this doesn't work. Try not to strain the front with it not being attached. Wow, that's absolutely fine. Testing 1 2, testing 1 2 3 4 5. So we'll show that on the air test. So I'll get this put back together, and then we'll come back to this video and we'll just put it on the aerial and finish off. Right, we're put back together. Let's get the aerial plugged in. And switched on. Why haven't I put the channel knob on? Well, I've got to make sure that channel 9 lines up. There we go. Right. Let's get the mic plugged in. One down to Roger. Over deviating. There's just so much every other word swearing, we just can't leave it on, can we? So we'll do an on-the-air test shortly with that, and that can go back to him tomorrow. We've done 3 sets for him, so I'll contact his intermediary tomorrow morning, and hopefully we can get those back. So thanks for watching the Midland 77104 UK with lots of faults.